Hello everyone. So for today's lesson, we are going to explore on trigonometric ratios of obtuse angles. But before that, probably we need to do some recall on what we've learned in Sec 2. Okay, so let us now do a quick recall on the three types of angles that we have learned so far. Okay, the first angle is known as an acute angle. Probably we can make use of this triangle ABC that I have right here. Okay, so for an acute angle, basically it's an angle that is greater than 0 but less than 90 degrees. Okay, so this angle BAC right here is an acute angle. Okay, the second type of angle that we have learned is an obtuse angle. Okay, so this angle ABC is an obtuse angle, and an obtuse angle is greater than 90 degree but smaller than 180 degree. Okay, the third angle that we have is a reflex angle. So if we look at this angle over here, this is a reflex angle. Okay, so this will be the reflex angle of BCA. Okay, so a reflex angle basically is greater than 180 degree but smaller than 360 degrees. Okay, so let us recall what else have we learned in Sec 2. Okay, so we have also learned Pythagoras theorem and how this Pythagoras theorem actually help us to find unknown length in a right angled triangle. I emphasize in a right angled triangle. Okay, so we have also learned how to write down the trigonometric ratios, and with this trigonometric ratios, how it actually help us to find unknown side or unknown angle in a right angled triangle. Okay, so let us do a quick recall on what Pythagoras theorem is all about. So Pythagoras theorem states that in a right angled triangle ABC, okay, the square of my hypotenuse, okay, it's equals to the sum of the square of the other two shorter sides. So which is why we have c squared equals to a squared plus b squared. So we can actually make use of Pythagoras theorem to find an unknown side given the other two known sides in a right angled triangle. Okay, so this is the use of Pythagoras theorem. Okay, so let us do a quick recall on trigonometric ratios of an acute angle. Okay, so let's say I have got this right angled triangle over here. Okay, so in a right angled triangle with respect to an angle theta, we must be able, okay, to identify my opposite, my adjacent, and my hypotenuse. So let's do a quick recall. So basically with respect to angle theta, okay, the side of the length which is opposite to this angle, we'll call it opposite, which in short we'll call it OPP, opposite, okay? So the side that is opposite to my 90 degree will be called my hypotenuse, okay? And the side that has got my 90 degree, my right angle, and my theta of reference, my angle of reference, it is called an adjacent. Okay, so if you recall your tuakaso, okay, I'm sure all of you would have remembered this. Okay, so by tuakaso, okay, we can actually write down the trigonometric ratios of an acute angle theta. Okay, since this theta over here is an acute angle. So for sine theta, okay, we're looking at so. So for sine theta, it's SOH, right? So it's sine opposite divided by hypotenuse. So sine theta is opposite divided by hypotenuse. Okay, so if I want cosine theta, cosine we're going to look at ka. So it's adjacent divided by hypotenuse. And as for my tangent theta, it is my twa. So it's opposite divided by my adjacent. Okay, so in this lesson, okay, we will actually learn how to find the trigonometric ratios of obtuse angle. Okay, so for today's lesson, we will learn how to find the trigonometric ratios of obtuse angles. But first, maybe we can do a small investigation over here. But I'll need you to have your calculator ready with you. Okay, so right here, I have got a table over here. I have indicated an acute angle and have also found out what its corresponding obtuse angle in my first table over here. So this table, okay, what I aim to derive at the end of the investigative activity is to find the relationship between sine theta and sine of 180 degree minus theta, cosine theta against cosine 180 degree minus theta. Okay, so first thing first, we will fill in our sine theta column as well as our sine 180 degree minus theta column first. Okay, so probably what I need you to do right now okay, we'll just focus on the first table of this two, we'll focus on this table, the first table here, looking at these two columns over here. Okay, before we look at the second table with these two columns over here. So what I need you to do right now, okay, after listening to the instructions, you may pause your calculator to fill in the values as calculated. So what I need you to have right now with you, it's your calculator mode. Okay, make sure you have checked that your calculator is in the D mode, the degree mode. Okay, because all my angles right here are measured in degrees. Okay, so what I need you to do right now is to key in sine of 30 degree, record this value, okay? And then as for this cell over here, I'll need you to key in on your calculator sine of my 150 degree and to indicate the value here. So I need you to do the same for this three sets of angles, okay? Okay, now let us do a check on what you have calculated using your calculator. Okay, so this is the table that we have. Maybe we can do a quick tally on the answers. Okay, leave your answers correct to 3SF. Okay, so I want you to make an observation between sine theta's value versus sine 180 degree minus theta's value. Okay, so I want to compare this with this sine theta against my sine 180 degree minus theta, and this with this. Okay, do you make an observation? Yes, you would have noticed that sine theta is equals to sine of 180 degree minus theta. It doesn't really matter whether your theta is an acute angle or an obtuse angle over here. You'll notice that they are actually equal to each other. So this is the observation that I have made. Okay, sine theta equals to sine of 180 degree minus theta. Okay, so maybe now we can actually do the same, okay, for my next two columns, for my cosine theta and my cosine 180 degree minus theta. Okay, so right now we will fill in these two columns. So in a similar manner, okay, after listening to the instructions, you may pause the video for you to make use of a calculator to key in the values and to record the readings. Okay, so in this case, for example, okay, for cosine theta, I'm going to key in on my calculator cosine 30 degree. Okay, same piece of reminder, make sure that your calculator is in your D mode, your degree mode. Okay, so after keying in cosine 30 degree, I need you to record down the reading that you see corrected to 3SF in this cell over here. Okay, so in a similar manner, I want you to key in cosine 180 degree minus theta, which in this case will be 150 degree. So I want you to key in cosine 150 degree and record the value. Okay, corrected to 3SF. So in a similar manner, I'll need you to do the same, okay, with the use of a calculator to record down this remaining three sets of theta and 180 degree minus theta. Okay, you may pause your video. Okay, come, let's do a check against what you have calculated. Okay, do you get these values? Okay, so once again, I want you to make an observation, okay, a relationship between cosine theta and cosine 180 degree minus theta. Okay, you notice that they are negative of each other, right? Okay, same thing regardless whether theta is an acute angle or theta is an obtuse angle. Okay, the cosine theta will always be the negative of cosine 180 degree minus theta. Okay, so they are always the negative of each other. So this is the relationship, okay, and the observation that we have made. Okay, so just to highlight, okay, cosine theta is the negative of cosine 180 degree minus theta. So with these two observations made, probably right now the burning question in mind will be, okay, why is this relationship so? Okay, so probably I can have this illustration for you to understand further. Okay, so let us take a look at this set of diagram. Okay, I've got two circles here. So in my first circle, okay, I have got a right angle triangle with an acute angle theta. Okay, so if the dimensions are given to me as this to be x, this length to be y, and this being the radius r of my circle, Okay, so according to my tuaka, so okay, sine theta, okay, is actually your opposite, okay, divided by hypotenuse. So it's y divided by r. Okay, so now if this theta is an acute angle, if I were to do a reflection against my y-axis, I would have my right angle triangle over here. So that makes this angle over here an obtuse angle, because this angle here would have been theta. So this angle over here would have been 180 degree minus theta, which is my obtuse angle. Okay, so if this side is x, okay, upon the reflection against my y-axis, this length here would have been negative x. My radius will always remain as a positive r, okay, so this part here will also be my positive y. So based on this, okay, I know that the sine of my 180 degree minus theta would have been my, okay, opposite over hypotenuse. So do you notice that both, okay, values are of y divided by r? So which is why we can actually draw a conclusion saying that sine theta is equals to sine of 180 degree minus theta. Okay, so in a similar manner, let us understand why so for the cosine theta case as well. Okay, so if this is my right angle triangle in a circle, so for cosine theta, where theta is an acute angle, it will be ka, which is adjacent, x divided by my hypotenuse r, so it's x divided by r. Okay, so for this diagram where I've got 180 degree minus theta, okay, cosine of this angle here would have been my adjacent, which is negative x, divided by my hypotenuse, which is r. So you notice that my cosine theta and my cosine 180 degree minus theta, okay, it's the negative of each other in terms of its value. Okay, so which is why we have got this conclusion of cosine theta equals to negative cosine 180 degree minus theta. Okay, so to sum it up, okay, this is an important summary for you to take note of. So to sum it up, sine theta will be equals to sine 180 degree minus theta, whereas cosine theta is equals to the negative of cosine 180 degree minus theta. Okay, so now let us take a look at some examples. So for my example one, okay, I've got this triangle right here, ABCD. Okay, BCD is a straight line where I've got a right angle triangle ABC. Okay, it's at 90 degree, and the dimensions are given as BC to be 5 cm, AB to be 12 cm, AC to be 13 cm. So I need to find the value of each of the following. Okay, so if I want to find sine of angle ACB, it's sine of this angle over here. Now it is a right angle triangle, so we're going to make use of our tuaka. So to find out what is the trigo ratio of sine angle ACB. Okay, so with respect to angle ACB, okay, to find my sine, which is me using my saw, okay, I'll need my opposite and my hypotenuse. So with respect to this angle ACB, this will be my opposite, this will be my hypotenuse. Okay, so I have my sine of angle ACB to be equals to 12 divided by 13. Okay, opposite divided by hypotenuse. Okay, so let's move on to part B. Okay, before that, okay, probably one point of reminder for you, okay, to take note is, in this example, we don't need to find out what is the value of the angle ACB, okay, because the question just want us to find the trigo ratio, which is a fraction, okay, of sine angle ACB. Okay, so I emphasize we need not solve for angle ACB because that is not required in this question. We just need to find the trigo ratio of sine angle ACB, which will be left as a fraction. Okay, so with that, let's proceed to our part B to find the value of sine angle ACD. Okay, now if you notice angle ACD, it's an obtuse angle. Okay, the obtuse angle of the acute angle ACB. Okay, so if you recall what we've just learned, okay, about the relationship between sine of this acute angle versus the sine of this obtuse angle, probably we can apply that in our part B right now. Okay, so sine of angle ACD Okay, sine of this angle here would actually be equal to the sine of this acute angle ACB. Okay, so sine of angle ACB is what we have found out in part A, which is at 12 divided by 13. So this will be my trigo ratio for my sine angle ACD. Okay, so this is what we have just learned earlier. Okay, so for part C, I'll need to find cosine angle ACB. Cosine angle ACB, this acute angle over here. So since this acute angle is in a right angle triangle, I'm going to use my trois quarts saw. So for my cosine, I'm going to use my car. Okay, so for cosine, it's adjacent. Okay, so with respect to this angle over here, this will be my adjacent, 5, and this will be my hypotenuse, 13. Okay, so cosine angle ACB will be adjacent divided by hypotenuse, which is at 5 divided by 13. Okay, so for part D, I need to find out what is the trigo ratio, okay, of cosine angle ACD, this obtuse angle here. So once again, if you recall what we have just learned, okay, the cosine of an obtuse angle is the negative cosine of my acute angle. So, okay, we have this cosine angle ACD equals to negative of cosine angle ACB. And I know that cosine angle ACB as found in part C is 5 divided by 13. So cosine angle ACD will be negative 5 divided by 13. Okay, so this is the relationship that we have learned just slightly earlier. Okay, so now let us take a look at our example 2. So in this diagram over here, I have got my right angle triangle WXY. Okay, I have got this straight line XYZ. Okay, and I'm also given the trigo ratio of sine angle XWY to be 4/5. So with this piece of information over here, okay, because this angle XWY is in a right angle triangle, okay, I know straight away that this is going to be my opposite. This is going to be my hypotenuse according to my trois quarts saw, my saw. Okay, so I repeat, okay, since it's given to me that sine of angle XWY is 4/5, this means that this is my opposite with respect to angle XWY, and this is my hypotenuse with respect to angle XWY. Okay, so I need to write down, okay, the following as a fraction in its simplest form. Okay, so since sine of angle XWY is 4/5, that means, okay, with respect to this angle over here, this is my opposite, this is my hypotenuse. So this is 4 and this is 5. Okay, so in order for me to find cosine of trigo ratio or even later tangent trigo ratio, I'll probably need this third length over here. So this is in a right angle triangle. So with two lengths known to me, I can actually make use of my Pythagoras theorem to find out the length of WX. So by Pythagoras theorem, okay, 5 square equals to WX square plus 4 square. Okay, by solving, it gives me WX to be 3 cm. Okay, so this is my Pythagoras theorem over here. Okay, so let's take a look at part A. For part A, I'll need to write down as a fraction my tangent angle XWY. Okay, XWY. So with respect to this angle for tangent, which is my trois, I'll need my opposite, I'll need my adjacent. So with respect to this angle, this will be my opposite, and this will be my adjacent, okay, which is 3 cm that we have just found out slightly earlier. Okay, so tangent angle XWY, okay, will be 4 divided by 3. This is my opposite divided by my adjacent. Okay, so for part B, I need to write down as a fraction, okay, in its simplest form for cosine angle WYX. WYX, let's take a look. WYX, this angle here, I'll need a cosine. So with respect to this angle, okay, for cosine is my car, I'll need my adjacent, I'll need my hypotenuse. So with respect to this angle over here, this will be my adjacent, and this will be my hypotenuse. So for part B, cosine angle WYX will be 4 divided by 5. Always check that your fraction is in its reduced form. Okay. Now let's take a look at part C. So for part C, I'll need to write down the fraction for cosine W, Y, Z. Okay, let's see, W, Y, Z. This angle over here is an obtuse angle. So if you recall what we have just learned about the value, okay, the relationship between cosine of an obtuse angle versus the cosine of an acute angle, they are actually the negative of each other. So I can actually say that cosine, okay, angle WYZ, okay, the cosine of this obtuse angle is the negative of cosine WYX, okay. And we have actually found out what is the ratio, what is the fraction for cosine WYX in part B. So part C, this would just basically be the negative of this value over here. Okay, so that gives me negative of this value, which is my negative 4/5. Okay, let us take a look at our last part D. Okay, I want as a fraction for sine WYZ. Okay, WYZ, this obtuse angle over here. Okay, so if you recall what we have learned earlier, okay, the sine of this obtuse angle will be equals to the sine of this acute angle WYX. So probably first we need to find out what is the trigo ratio for sine of angle WYX. Okay, so to get the sine of this, it is my opposite, okay, divided by my hypotenuse. Okay, so with respect to this angle, let me repeat, with respect to this angle, okay, my WX will be my opposite and my WY will be my hypotenuse. So which is why, okay, I say that sine of angle WYZ is equals to sine of angle WYX, okay, which is equals to 3 divided by 5 because of your so, okay, your tuaka so, which is opposite divided by hypotenuse. And I also know that the sine of an acute angle is equals to the sine of an obtuse angle, and hence they share the same fraction. So I hope after this session you will be clearer on how to find out, okay, the trigonometric ratios of obtuse angles. Thank you.